People say that we can't go back to the moon. Even Joe Rogan said that maybe reason we can't go back to the moon is to not disprove the moon landing, so is this true? Well, let's start there and flip it, because it is a fact that we have mission logs, landers that still work, and rocks in labs. Can't go back claims contradict the moon landing facts, so today I'll stack 3 kinds of receipts. Pictures that we can all see, lab reads from real samples, and rivalry milestones that force both sides to show their work. First, let's be clear about going back. Some folks mean boots on the ground. Others mean any mission that reaches lands, works, and returns data or samples. By that second meaning, we already went back many times. Landers touched down, rovers drove, sample capsules came home. If we can't go back, how did the rocks get here? Look at the far side of the moon, the side that we never see from Earth. A lander and rover worked there. Not a trick. Real power, heat control, and communication hops through a relay satellite. Samples from the near side came home years ago. Then samples from the far side came home too. Those are in labs now, and they do not care about internet arguments. It is a simple chain. Space hits the soil records the hit, labs read the record. So what's missing? Crews. Flying people need safety gates. Certification just means official proof the hardware meets strict rules. That takes time and repeated tests. China has a plan to land its astronauts before 2030. The US aims for a crew landing in the later 2020s. So crewed is coming, but the uncrewed back is already here. Claims don't change the readout, missions do. Now let's build the bundle that locks this down. 3 lanes. Lane 1 is lab fingerprints. Return samples tell a story in chemistry and structure. Some beads of glass in lunar soil hold tiny bits of water. That glass beads made by impacts in labs can measure the water in them. Spectroscopy is just how we read light from a sample to learn what it's made of. Lane 2 is visible receipts. Landers, rovers, orbiters, and even the first photograph of Earth from lunar distance way back in the 1960s. Lane 3 is rivalry. When a rival brings back their own samples, other teams can retest the same stuff. Pictures suggest, samples decide. That's why we stack methods, not opinions. Close-up rover photos on the far side replace guesswork with detail. Orbital images from decades ago line up with modern high-res shots. You can cross-check craters and landing sites across time, and when samples arrive on Earth, new labs can run new tests on old questions. The bundle tightens, piece by piece. And this isn't slowing down. More missions are already queued this decade. That means more landers, more cameras, more temperature logs, more radios chirping across space. It also means more rocks in new bags. When a rival can redo your test, the claim collapses into a footnote. Because then it's not your word against mine, it's measurements against measurements. Engineers say this all the time, and yes, Elon Musk repeats it in public. Independent verification beats staged footage. Okay, let's tackle the most common we can't go back supports. First, the stars. People ask, where are the stars in these photos? Bright ground, short exposures, the stars don't show. That is a camera fact, not a cover-up. Try the same thing on a phone at night. Aim at a bright street lamp. The sky goes dark. The stars are still there, your camera just isn't set for them. Next, the radiation belts around Earth. The Van Allen belts are zones of high-energy particles. They are not a wall. You plan a path called a trajectory that passes through the thinnest parts. You go fast to limit time there. You shield the spacecraft, measure the expected dose, compare to safe limits. Engineers did this math then, and they do it now. Meanwhile, landers and rovers survive lunar day-night cycles and keep sending pictures. What about, we lost the tech? Well, that line sounds big, but it's simple. Factories close, tools get retired, teams move on. When you rebuild, you don't photocopy 1969. You design new vehicles for new goals. That means new tests, new rules, new parts, and yes, delays. Delays prove process, not that it can't be done. Airplanes get redesigned, bridges do too. Spacecrafts are no different. Now the rang like a bell claim. After small impacts, the moon's crust vibrated in a way that lasted longer than people expected. That sparked hollow moon talk. But this is seismology, the study of quakes, and the moon's dry, cracked crust carries vibrations differently than wet Earth rock. Seismometers read that. More data match the model. The Bell line is a half quote, not a mystery. What about mystery structures and blurry images? A rover actually drove toward one hut shape on the far side. As it got closer, the building turned into what it was, a rock on the rim of a small crater. The rover taught a bigger lesson. Getting closer kills the illusion faster than any debate. That is our theme today. Vibes fade when measurements arrive. If someone tries to argue against one, the other two are still there. So why aren't crews there already? The blockers are not magic. They are budgets, safety gates, and new hardware. Brand new rockets need multiple test flights. New landers must show that they can land, climb back off the surface, and keep crews alive. This year, a new lunar lander and another program completed a landing and takeoff test profile. A new heavy rocket stage fired as planned. Those are the steps you need. Rivalry adds pressure, which adds proof. NASA's leadership says that they don't plan to lose this race. Lawmakers held hearings to stress why it matters and where the money goes. That oversight forces schedules, audits, and more public updates. Every milestone a rival hits is another image, another lab, another logbook. Even the arguments push teams to show more data. Timelines also shape how we read claims. The U.S. aims to land a crew with its current moon program in the later 2020s. China says before 2030 for its first crewed landing, likely near the South Pole. The South Pole area has peaks with sunlight most of the month and craters where ice can survive. That hints at longer-term bases, not just flags and footprints. Competition speeds up the only thing that counts, repeatable numbers. Let's look forward. What receipts are coming next? More uncrewed lunar missions are planned this decade. 3 big ones are slated before 2028. Expect more landers, new sites, and fresh samples. Each touchdown gives us thermal data, dust behavior, and surface pictures that you can match with older orbital shots. Each sample bag becomes a lab day for teams around the world. Labs will chase new signals in those samples too. For example, some teams reported signs of carbon, even graphene, a 1-atom-thick form of carbon in lunar dust. That is a bold line. It needs careful retests by independent groups. And that's the point. The next samples won't end debate, they'll narrow it until only the measurements are left. That is how science grows. That same program then returns samples that any lab can request and test. Watch the rockets as well. A giant new rocket completed its 10th test flight and hit key goals. More lift means bigger cargo, stronger landers, and heavier lab gear riding to the moon. That feeds the bundle. Better pictures, better instruments, more sample capacity. The whole field gets sharper when the rockets level up. You will see that in the data released after each flight. And you can't land on the far side, beam back pictures, and then pretend that you didn't. Keep an eye on crew systems getting human rated, which just means cleared for people. Capsules must prove they can keep an atmosphere, handle heat on re-entry, and abort safely if the rocket fails. Landers must show gentle touchdowns and clean liftoffs. Suits have to flex, hold pressure, and reject dust. Expect test videos, test logs, and test failures. Failures teach, passes stack. That is how science wins internet fights. You pull the thing apart, measure it, and let anyone redo your steps. Also, expect more cross-checks between rivals. One side will claim a new mineral form or a new water source in the soil. Another side will run the same test on their own material. If a new signal shows up, expect 3 teams to chase it. That's the point. Replication turns claims into facts. It also kills errors before they spread.